Imagine diving into the ancient oceans of Earth 230 million years ago, where the sunlight barely penetrates the deep blue waters and shadowy shapes move in the distance. Suddenly, from the darkness emerges a creature so enormous it defies belief. A monstrous predator longer than a school bus, with eyes the size of dinner plates and jaws capable of crushing bone. This wasn't just another prehistoric animal. This was Shonisaurus sikanniensis, the largest marine reptile ever discovered, a true leviathan that made even modern blue whales seem small in comparison. Today, we're going to explore every incredible detail about this forgotten giant of the deep, from its shocking discovery in the Canadian wilderness to its biology, hunting strategies, and mysterious extinction. By the time we're finished, you'll understand why scientists consider this creature one of the most formidable predators to ever rule Earth's oceans, and why its story remains one of paleontology's greatest mysteries. The tale begins in the remote mountains of British Columbia, where in the early 1990s, paleontologists were conducting routine fossil surveys along the banks of the Sikanni Chief River. What they found would rewrite our understanding of prehistoric marine life. Protruding from the rocky cliffs were enormous vertebrae, each one nearly the size of a car tire, that initially appeared to belong to a dinosaur. But as excavation continued over multiple field seasons, researchers realized these bones told a different story. They weren't looking at land-dwelling giants, but at the remains of an immense marine reptile from the Triassic period, a time when the first dinosaurs were just beginning to appear on land. The creature would later be named Shonisaurus sikanniensis, and it would shatter all previous records for size among marine reptiles. When scientists finally reconstructed the complete skeleton, the numbers were staggering. The largest specimens measured approximately 69 feet 21 meters from snout to tail. That's longer than most modern sperm whales and approaching the size of adolescent blue whales. But what truly set Shonisaurus apart wasn't just its length, but its incredible bulk. Unlike the slender builds of later ichthyosaurs, Shonisaurus had a massively thick body, with some ribs measuring over 3 feet long. Paleontologists estimate it may have weighed upwards of 50 tons, making it heavier than many humpback whales alive today. The skull alone measured nearly 10 feet long, housing powerful jaws lined with conical teeth perfect for gripping large prey. Perhaps the most striking feature of Shonisaurus was its eyes, the largest of any known vertebrate in Earth's history. Fossilized sclerotic rings, the bones that support the eye, suggest its eyeballs could have been 10 to 12 inches in diameter, larger than a bowling ball. These enormous visual organs were likely an adaptation for hunting in the deep ocean's perpetual twilight, where sunlight barely penetrates. Modern giant squid, which dive to depths of over 3,000 feet, have similarly large eyes for detecting faint bioluminescent signals. This suggests Shonisaurus may have been a deep diving predator, plunging into the abyss to hunt creatures that never saw sunlight. But how did such a massive creature move through the water? Analysis of its flippers provides fascinating clues. Unlike the slender wing-like flippers of later ichthyosaurs, Shonisaurus had short, powerful paddles, more like a sea lion's flippers than a dolphin's. This unique anatomy suggests it wasn't built for high-speed chases, but rather for sudden bursts of acceleration. Scientists theorize it may have hunted using ambush tactics, lurking in the darkness before exploding forward to ram its prey with incredible force. The impact alone from a 50-ton predator moving at even modest speeds would have been enough to stun or kill most marine animals of its time. The environment Shonisaurus inhabited was unlike anything in today's oceans. During the Late Triassic period, about 237 to 201 million years ago, all Earth's land masses were joined together as the supercontinent Pangaea, surrounded by a single global ocean called Panthalassa. The seas teemed with life forms that would seem alien today. Giant ammonites with coiled shells 6 feet across, early sharks with bizarre spiral-toothed jaws, and other marine reptiles like the dolphin-shaped ichthyosaurs and long-necked plesiosaurs. But Shonisaurus sat firmly at the top of this food chain. Its only potential competitors were other large ichthyosaurs, though none matched its sheer bulk. What allowed Shonisaurus to grow so large? Several factors likely contributed to its gigantism. The Triassic oceans were exceptionally rich in nutrients, supporting vast populations of prey animals. There were no modern-style whales or large sharks to compete with for food. Additionally, some scientists believe higher oxygen levels during this period may have supported larger body sizes in marine reptiles. But perhaps most importantly, Shonisaurus lived during a time when evolutionary pressures favored size. Being bigger meant fewer predators could challenge you, and you could hunt larger prey. The diet of Shonisaurus remains partially mysterious, but fossil evidence provides some clues. While some earlier ichthyosaurs had slender jaws for catching small fish, Shonisaurus possessed robust jaws capable of handling much larger prey. Some paleontologists suggest it may have fed on giant Triassic squid, which could grow over 30 feet long. Others propose it hunted smaller marine reptiles, or schools of large fish. The teeth of Shonisaurus are particularly interesting. They're conical and slightly curved backward, perfect for gripping slippery prey but not for chewing. This suggests it likely swallowed prey whole, much like modern sperm whales do with giant squid. One of the most fascinating aspects of Shonisaurus biology is its potential for deep diving. Several lines of evidence point to this capability. The enormous eyes we discussed earlier would have been perfect for low-light conditions in the deep sea. Additionally, the bones of Shonisaurus show adaptations similar to modern deep-diving whales, thickened ribs and vertebrae that could withstand tremendous water pressure. Some researchers estimate it may have been capable of diving to depths exceeding 3,000 feet, holding its breath for 30 minutes or more. This would have given it access to food sources unavailable to most other predators of its time. The growth and lifespan of Shonisaurus are subjects of ongoing research. By studying growth rings in fossilized bones, similar to tree rings, paleontologists have estimated these creatures may have taken 30 to 40 years to reach full size, comparable to modern large whales. This slow growth rate suggests they had relatively long lifespans, possibly exceeding 70 to 100 years. Interestingly, fossil sites have revealed groups of Shonisaurus specimens of varying ages buried together, leading some scientists to propose they may have lived in social groups or migrated in pods, much like modern whales. The extinction of Shonisaurus coincides with one of Earth's most catastrophic events, the Triassic-Jurassic mass extinction, about 201 million years ago. This event, possibly triggered by massive volcanic eruptions from the breakup of Pangaea, wiped out nearly 80% of marine species. For Shonisaurus, several factors likely contributed to its demise. The changing ocean chemistry may have disrupted its food chain. Rising temperatures could have affected its deep-diving hunting strategies, and the emergence of new predators like early plesiosaurs may have outcompeted the remaining ichthyosaurs. While some smaller ichthyosaur species survived into the Jurassic period, none ever approached the size of Shonisaurus again. Modern technology continues to reveal new secrets about this ancient giant. CT scanning of fossils has provided 3D models of its brain case, showing it had relatively large olfactory lobes, suggesting a good sense of smell to locate prey in the vast ocean. Computer simulations of its swimming mechanics indicate it was likely slower, but more maneuverable than previously thought, capable of tight turns despite its massive size. An isotopic analysis of its teeth is helping scientists reconstruct ancient ocean food webs and migration patterns. The legacy of Shonisaurus extends beyond just being the biggest. Its existence proves that marine reptiles achieved sizes comparable to modern whales tens of millions of years before whales evolved. It demonstrates how different evolutionary paths can lead to similar solutions. Streamlined bodies, deep diving capabilities, and gigantism all evolved independently in ichthyosaurs and whales. And its sudden disappearance serves as a cautionary tale about how even the most dominant species can vanish when environments change too rapidly. As we continue discovering more fossils, particularly in underexplored regions like Arctic Canada and New Zealand, who knows what other secrets about Shonisaurus await revelation? Perhaps even larger specimens will be found, pushing the boundaries of what we thought possible for marine reptiles. Or maybe we'll uncover evidence of even more bizarre behaviors. For now, Shonisaurus remains one of paleontology's most magnificent enigmas, a reminder of a time when Earth's oceans were ruled by creatures beyond our wildest imaginations. So the next time you look at a blue whale and marvel at its size, remember that 200 million years ago, something even more massive may have been lurking in the depths, a true monster of the ancient seas whose story we're only beginning to understand. What other lost giants might be waiting to be discovered in Earth's rocky archives? And what lessons can these prehistoric titans teach us about the fragile balance of marine ecosystems today? The answers may still be out there, buried in layers of stone, waiting for curious minds to uncover them. If you found this journey into deep time fascinating, imagine what other prehistoric mysteries we could explore together, from colossal dinosaurs to tiny creatures that changed the world. The history of life on Earth is more incredible than any fiction, and each discovery rewrites what we thought we knew. So stay curious, keep exploring, and who knows, maybe you'll be the one to uncover the next great paleontological revelation. The past, after all, is never really gone. It's just waiting to be rediscovered.